Today we're going to talk about isometric views. We've gone over orthographic views, but isometric are a little bit different. Isometric projection is a method for visually representing three-dimensional objects in 2 dimensions in technical and engineering drawings. They look 3-dimensional. If we look at the B1 drawing, which we've kind of touched on a little bit, it looks 3-dimensional. You can see the entire shape, but it's 2 dimensions. And the way that they get that 3-dimensional effect is drawing at 30-degree angles, which is the 30-60 triangle that you have is what's used to draw these. So the B1 drawing is an isometric drawing. And these are some examples of other type of isometric drawings. A cube, you see it's 30 degrees angle at the bottom of the cube. Here's another isometric drawing and another isometric drawing also. So it's just examples of what we're going to be looking at and kind of delving into a little bit here, touching the, just the outer surface of it. So isometric drawings can be difficult to understand and to put onto paper. You'll need a couple triangles to help you construct the drawings. So the first is a 30-60, which is one that you will use more often than the 45. You can see that on this we have 30 degrees here, and then you have a 60 degrees right here, and then 90 right angle at the bottom. And also it's the 45-degree triangle, which again has 245 edges on it and a right angle down here at the bottom, 90 degrees. Same with this, 90 degrees. So it's this angle that we're going to use quite a bit for isometric drawings, the 30 degrees. So some things to keep in mind when drawing isometric paper drawings. If you don't have isometric paper, you need to use a base construction line, a horizontal line you draw across a blank paper. All horizontal lines of the actual drawing are done at 30 degrees, but your construction line is a straight line across the bottom of the page or the center of the page. You can make as many as you want, but generally they're erased at the end of the drawing. All vertical lines, whether it's a plumbing vent or a plumbing drain line, they are all straight up and down vertical. So again, there's 60 degrees, and here's your 30-degree angle. This is an example of isometric paper. Some of you may or may not have it. If you don't have this type of paper, you have to make a construction line. So these lines are 30 degrees. All the lines that you see going at a 30-degree angle horizontally across the page, these are all used for your horizontal lines. And all these are vertical. So if we take a look at this isometric, this is just a simple isometric cube. And it's one of the first things I do when teaching. We have to put up some construction lines. So like I said, a construction line, the first one you make is going to be your horizontal line. There's no length to it. It doesn't matter. You just make a line as even as you can across the page, because you're going to put the triangle on this line all the time, and it's going to make sure that your picture, your drawing, is perfect. Like everything the triangles will all line up. So we have here 230 degrees lines. It's typical for them, and that's the way you start your drawing. Now the cube is in the center here, so the drawing would be done. Once you've established this, you would erase your construction lines from here right along the bottom, and from here to here, and from here to here, leaving you with just the cube. These are 2-dimensional drawings, again, using the 30-60 triangle. And the concept itself starts with a vertical line at the base point. So here's your vertical lines at the base point. And keep in mind, all lines when doing isometric go in the same direction. So they're parallel. This line is parallel with this line. This line is parallel with this line, and this line, and this line. So you notice in isometric, the lines don't cross, because then it wouldn't be a two-dimensional drawing anymore. So here's a couple little basic rules, and some of this gets a little too further into it than what we're going to actually touch on. But as I said, all vertical lines are drawn up, for instance, for a plumbing vent. All vertical lines are drawn vertically down for a drain, such as this here. You always try to keep the trap arm right here going in the same direction of flow. So if you were to draw a trap, you go here 45 down and then down into the drain for vertical. You wouldn't take this line here, and what we don't want to see is you go this way with it and then come back up and down. So the trap is going to go in the flow direction. All horizontal pipes are drawn at a 30 degrees angle. There's the 30-degree angle. A 60-degree angle is shown to show a Y and a 45 off of a 30. So this is trying to show a Y fitting coming off of your 30-degree angle here. Okay, and again, we're not going to get into this as deep right now, but you must show a real Y if you have an isometric horizontal pipe and the Y connection is on its side. It's drawn at 0 degrees if the branch is from the right to the left. So here's our 30 degrees. Here's a branch line coming off of it, and this actually forms what looks like a Y. So we're going right to left. So you come straight into it. We're on the right side of the main trunk. And if you have a left to right connection, the Y connection, it's a vertical 90 degrees. So it's drawn this way if it comes off of the left side of the trunk. These are the same fittings, drawn a little bit different. If you had a construction line, you would come straight up vertical and then 30 degrees this way. And then finally, if you have an isometric horizontal pipe with a 45 pipe, tying into it is drawn at a 90 degrees angle. But we're not going to touch on that right now and get that in depth in this video. So here's a simple isometric drawing. It shows a bathtub drain or a shower drain. We don't know, but it's in the ground, so I'm going to assume this is going to be a bathtub. And here we have a basin sink. So two fixtures and drawn in a simple isometric. Again, this would be your construction line you've made. You put your triangle on it, and you would simply draw the 30 degrees line. Everything vertical. Here would be the drain, and here would be the vent. So this is all drawn vertical 90 degrees off of that construction line, straight up. So there's your bathtub and this drain line, and a basin trap in this drain line. This here, the horizontal will be drawn at a 30-degree angle, which is the main drain, or horizontal branch, depending what this is all tied into. Isometric drawings use a compass to navigate around the drawing. So if you're not familiar with a compass always points north. So if we take a look at this, you know, these little diagrams here of a compass, north is always at the top, south is at the bottom, W to the left, east to the right. One thing you can always try to keep in in the back of your mind, if it helps you, you think north like the northern stars straight ahead up above. W and E is we, and south for the southern hemisphere, if you like. But the trick to it is north is always at the top, and then WE. It's never E over here and never W here. It's always W and E. And then you have northeast, southeast, southwest, and northwest. And really it's taking quarters and dividing it into 8. Now let's look at a little more in depth into this. If we're given north as a heading, we can figure out how to draw the orthographic shapes as isometrics. So here's the orthographic shape that we're going to start dealing with. Notice that north is shown in the example below. So let's draw the southwest view. So that's where you would be looking. So, not looking, you'd be standing and looking. So when I ask for a view, you have to picture yourself here looking this direction, right? Some students get confused thinking they got to be here looking to the southwest, but that's not how it works. You are actually standing here looking from the southwest. So remember, you are drawing from the compass location, not towards it. So if you're asked to draw southwest, you have to picture yourself in the southwest location and draw what you would see. So if we move the compass over, now you can see that the blue arrow and the compass land on southwest. And you're actually drawing towards the northeast. Okay, so again, you have to picture yourself in the southwest looking at the object. Now, we've talked about top view, side view, front view in orthographic. The plan view is the same as top view. The elevation is looking straight on at an object. Now, in this example, it gives you the east elevation, which is basically the side view from the east. The best way to explain elevation view is if you're riding in an elevator and the elevator door opens and you step off and you look directly straight in front of you, everything you see would be an elevation. Another way of kind of thinking about elevation view is if, maybe at some point your sister had a Barbie doll house, or hey, maybe you had a Barbie doll house. It's all good. But you open up the Barbie doll house and it would be full of rooms. That's the elevation view. You're looking dead on at everything that what's in front of you. So elevation can be considered a front or side view. Basically, for isometric, you're going to have two views. You're going to have a plan view and an elevation view. And that should be enough to allow you to do the drawings. So let's draw this orthographic figure in isometric. Picture yourself standing in the southwest location looking in towards the drawing. Okay, we're standing there and we're looking in towards this drawing. Using both the plan, which is the top view, and the elevation or the side view, try and picture what you are looking at. So you have to take a peek at this and remember your orthographic rules and whatnot to figure out the actual shape itself. So the point where you're standing is the lowest point of the 30 degrees horizontal line you must draw. So if you're standing here looking into this, this is the trunk of the drawing. The main part is going to be on the 30 degrees angle. So these will be on 30 degrees and so will these because they're parallel, right? But This point will be the low part of that 30 degrees rise. So it starts here, it rises up, finishing here. So wherever you are is the lower end of the drawing, and you're always rising up. If we look at this from the top view, the plan view, here we have a 90 going down. When you see that from the side view, the 90 is coming along here and it turns down. It's coming along here and there it is turning down. From the top view, we see we have a flat 90 here, and then it goes to a flat T, and then two flat 90s. Now, what we have to keep in mind with this is that you can't necessarily figure this out all on your own. You need to have the two views. So again, from the top view, you have a flat 90, a flat T, two flat 90s, just simply going back. If we look from the side view, so we would be, this is us looking dead on to this fitting, would be us here looking dead on to this fitting. This would be a 90 going away from the viewer. So there it is there. It would be going that way. We'd be standing here looking at it, and it's a 90 going away. So here's the actual drawing completed. If you want to take a moment, pause the video, and maybe try to sketch out something. Maybe you've got it, it'll kind of give you the idea of whether you've got it or not, or you're in the ballpark. Okay, so here we go. This is the drawing completed. So hopefully you got something similar, or you kind of get the idea. The 30 degrees triangle is really being used here. Then you would flip the triangle and you go here, and you flip the triangle again and you do these two final lines. This is vertical to the construction line that you have at the bottom. This is just straight up and down, which is this part here, which is the pipe that's hidden underneath this 90. So if we put the compass over it, remember we are drawing from the southwest. So we're down here now, because that's where we're looking for. You are in the southwest. Down here, looking into this. So here's the line coming down, and the pipe drops down, right? Pipe comes across, pipe drops down. Pipe comes across, pipe drops down. There it is there. So it really takes time to sit and figure out what you're looking at, and to remember that wherever you are located, you are at the bottom of the 30 degrees angle. So the lower end of the line. Okay, that's your view. That's where you're looking from. And that is the final drawing. Okay, because if you break this down, you have a pipe. Oh, let's just call it line. You have a line coming here, and you have a line coming across here. So from the top view, if you're up here looking down on it, you would see this coming across, which is this, right? Then you have this here line, which is this. And then you have these two back lines here. And that's them right there. Now you notice at this point in the game, there are no hubs on the isometric drawing. None of these, right? These slashes here, if you will. So there's none on the isometric for now. And some teachers are different. Some teach it with it, some teach it without. For now, we're not going to be using any hubs. So I would consider this drawing to be completed, right? No hubs. It is just the way I would expect it to be done. So let's try to break down the drawing just a little bit more. I'll go over it one more time with you here. You are here, right? This is your view looking in this direction, right? Because we're going with the southwest view. If you look up here, here's the southwest, which puts you up here, looking inwards, right? So there you go. That's your view. So wherever you are located is the lowest point of the 30-degree horizontal line you must draw. This is your 30 degrees line. Down here you'll have your construction line, but this is your 30-degree line. And this is you down here. This point's really the closest to you. I know the little man is this close, but you could be way back here. It doesn't matter. This is the lowest point, and it rises on the 30-degree angle with your triangle. So there's the lowest point. This is the top of the 30 degrees horizontal. All the lines are parallel. All these lines are 30 degrees. It's just a matter of flipping your triangle one way or the other. So what if you put the two drawings and the isometric, or the orthographic and the isometric drawing side by side? So the orthographic is the drawing on the right, and the isometric is the drawing on the left. They both show the same thing. The benefits of the isometric, you can see everything in one drawing, where the orthographic, you need 2 or 3 versions to see the entire drawing, because you don't know what's hidden behind some of the symbols. Where on the isometric on the left, you can see everything. So let's get our directions in here. We'll put the compass settings in, and maybe it will help you a little bit more. So here's north on the isometric, and here's north on the orthographic. And the reason I know this is north is because in all these, for the most part, you'll get some kind of a compass heading. This is pointing north is in this direction, so here's north. Then we have south. So where's south going to be on this one? Is it here? Is it here? Well, south is always below the N. So here's west. Remember we talked about WE, west and east. So we know that on the other side of the W is the east. If you look at this drawing, and we're in the plan view, so we're looking down on top of it, like you're a bird flying, through the clouds, looking down on something. The west side, if we're looking at this, we've got a pipe coming towards us and a pipe kind of going away. Here's our west view, and here's the pipe coming towards us, and it's kind of going away, or flat to the viewer, if you will. So hopefully this helps you. It's a little tricky, but take your time with it. See some of the videos, and hopefully we'll be okay. And that's it. Thanks so much for watching.